Dear friends, engineers, architects, and students of architecture engineering, uh, this particular series once again taken by me, VK Jain, who had a track record of 35 years service in Central PWD, which is the department for taking up central government building works. This particular series is about captive power and diesel generating sets, captive power in general and diesel generators in particular. Dear friends, before we proceed further learning standby generating sets, let us learn some terms which are normally required during discussion about standby power supply. Now, there are three terms I will like to mention here. Captive power. Captive power refers to generation from a unit set up by industry for its exclusive consumption. A captive power plant for standby is a is a power plant installed and used by the industry or any other user for generation of electric power when licensee supply is not available. By licensee, I mean electricity board. A captive power plant for dedicated use is a power plant installed by the industry for generation of electrical power for all times except when the plant is not available. So we'll work on that. A cogeneration facility is defined as one which simultaneously produces two or more forms of useful energy, that is electrical power and steam electric power and shaft uh, alike. A consortium-based dedicated captive power plant is a power plant owned by a group of industries for some use or at all times except when this plant is not available. Distributed generation is a new concept. New, by new I mean at least 10 to 15 years old concept. By definition, distributed generation involves the technology of using small scale power generation technologies used in close proximity to the load being served. Say we have learned mostly about big powerhouses uh, which are coming for power generating stations based on coal fired and hydel or atomic energy. But the current trend is the the move toward on site distributed power generation is accelerating because of the impending deregulation and reconstructing of utility industry. In the appropriate reconfiguration, distributed generation technology can improve power quality, boost system reliability, reduce energy cost, and help delay or defray substantial utility capital investment. Generating sets are commonly classified based on fuel, application, installation, capacity, and control. Below is a clear classification. We'll work on based on fuel type. There can be diesel generating set and These are most common, reliable and high efficiency. They are used in building, hospital and industries. Second, petrol generating set. Uh, they are small capacity but portable, used for homes and small shops. Third, gas generating set. Gas-based generating sets are many types. We'll learn a little later. They use natural gas, LPG or CNG. Three different or a combination of these. These are cleaner emissions producing generating set, and they have lower running cost also. Fourth, bifuel or dual fuel generator. That means they are a combination of diesel generating set plus gas generating set. In this case, a fuel flexibility. Fifth is biofuel generator, where they use biodiesel or biogas, and they are environment friendly. Friends, we are discussing generating set of different types. The first column of this table shows fuel or energy source. Second shows the generation cost, rupee per kilowatt hour, and their specialty. Third column, coal-based thermal plant, which occupy maximum portion of our energy generation. They have they are currently costing 4 to 5.5 rupee per kilowatt hour, and these are the currently conventional base load cost given here. Second one is natural gas type. The cost is little higher, from approximately rupees 5 to 7. This higher cost is due to fuel price variability. Hydropower, where old source of electricity generation, they cost 4.5 to 6. The cost varies by scale and site. Small hydro, 5 to 6.5, slightly higher cost for smaller plants. Solar PV. This is a new source type for last 10 years, and they are yielding very low generation cost, which is 2 to 3 rupees per kilowatt per unit. Then wind onshore and offshore, there are two types. The wind onshore is costing 3 to 3.6. The cost depends on wind availability and capacity factor. Biomass. This is whatever कचरा वगैरह हम कलेक्ट करते हैं फिर उसको जलाकर एनर्जी पैदा करते हैं. They are yielding low cost, often with seasonal fuel constraints. Bagasse cogeneration. This Bagasse cogeneration means out of uh, bagasse created by sugarcane sugarcane dealing, they generate bagasse type cogeneration, and these are typically used in sugar mills. They have also a very attractive cost. 2.5 to 3.5. Then urban industrial waste to energy, uh, the cost may vary. Higher variability depends on waste quality, waste collected by that particular city. Nuclear power, traditionally in vogue for last 60 to 70 years, the cost is higher. It is long life plants, capital intensive. This is regarding DG set as per CPCB norm, Center Pollution Control Board, CPCB. It prescribes the whatever may be the generating set, there is a noise limit of 75 dBA absolute at 1 meter second, acoustic enclosure, factory built. Third, weatherproof for outdoor installation. Fourth, vibration isolation, anti-vibration pads are spring mount mandatory. The enclosure shall be weatherproof, corrosion resistant, and provided with A. Lockable doors, B. Ventilation levers, C. Exhaust opening with flexible bellows. Next is CPWD General Specification for Electrical Works Part 7 DG set is the India government standard for installing diesel generating sets covering everything from engine alternators, control panels, and AMF automatic mains failure panel, foundations, the method of synchronizing, incorporating CPCB norm for noise emissions, and requiring 120 hour trial run for acceptance, ensuring safe, sufficient, and reliable power backup systems with updates reflecting latest technology and safety standards. Friends, this is regarding performance and other details. A diesel generating set should be considered as a system uh, with its successful operation depends well-matched performance for components, namely the diesel engine and its accessories, AC generator and its voltage regulator, the control system and switchgears, generator cooling arrangement, canopy for soundproofing or sound attenuation, that is silencer. It should have turbocharger beyond certain capacity. The foundation and powerhouse civil work, the connected load and with its components like heating, motor drive, lighting, etc. The major components of the generator are generator housing and stator, generator rotor and exciter, automatic voltage regulator, emergency trip controls, and relays. Major component of the engine and its support system are governor, speed governor, starting system, that means uh, air or electric, and DC battery, fuel oil delivery system, combustion air intake, turbo and aftercooler, exhaust system stack, lubrication system. Now this exhaust system stack, I'll give you details little later in this presentation. Friends, now we'll talk of diesel generating set applications. Diesel engine power plants are most frequently used in small power, captive, non-utility. Non-utility means without electricity board. The main reason for their extensive use is higher efficiency of diesel engines compared with gas turbine and small steam turbine in output range considered. In applications requiring low captive power without much requirement of process steam, the ideal method of power generation would be by installing diesel generating plants. The fuel burnt in diesel engine range from the light distilled to residual fuel oils, normally HSD, high speed diesel oil, and LDO, light diesel output. For continuous operation, low speed diesel engine is more cost effective with high speed diesel engine. Diesel generating services are available from sets are available from 2 kilowatt to 800 kilowatt for 450 15 volts 50 hertz AC, which is commonly available. These can be air-cooled types for lower ranges up to 55 kilowatt capacity, after which they are always water-cooled type. The generating unit will have single DG engine for sets up to 400 kilowatt, after which two diesel engine will drive one alternator, twin generator system. Diesel engines should be selected as per Indian Standard 1600 or 1601 as may be applicable. Similarly, alternators should be as per Indian Standard 4722. Friends, this slide shows the isometric view of a generating set and its various components. We'll talk one by one. This yellow portion up to here is diesel engine, up to here, and it is coupled with alternator, that means generator number 2. Third is the fuel tank, which is here. Then fourth, lubrication system, it is here. Fifth is cooling system. Which is here. Sixth is starting system, here. This is solenoid operated type. Seventh is exhaust system, this one. And this may be very elaborative. Eighth is the control panel here, provided with the set, diesel generating set. Ninth is air intake, and 10th shows the battery. Battery is a part of a starting system. Friends, this is also diesel generating set, but it shows some other components also. Let us begin. This portion is diesel engine coupled with the alternator or generator, and this generator has got its voltage regulator and control panel here. Some other thing which were not in previous slide is vibration isolator are provided over the chassis. Chassis is a base frame over which the entire generating set is mounted. Now, this radiator is the cooling system, provides cooling system, and there are certain air filters provided in the system, which of course not extensively used in my lecture. Friends, the diesel generating sets are available in following standard capacities, all in kVA: 7.5 to 62.5, then 75 to 380, and 415 to 1500. Capacity output of diesel generating shaft should be specified in tender in terms of prime mover rating at 0.85 load factor as per clause 13.3.2 of ISO 8528 part 1, titled Reciprocating Internal Combustion Engine Driven Alternating Current Generating Set part 1. Application rating and performance. However, depending upon the particular application and use, continuous or standby rating can be specified. Friends, we are discussing now supercharger or turbocharger type diesel engine system. The supercharger forces air into the engine at higher than atmospheric pressure. A supercharger is a mechanical air compressor that pressurizes the air going into engine. A supercharger is an air compressor and it requires a source of power to operate the compressor mechanism. Most automotive superchargers are run by a drive belt or occasionally a train of gears operated by the engine, much like a power steering pump or air conditioning compressor. An alternative is to turn the supercharger with a turbine wheel placed in the engine's exhaust manifold, turned by the flow of wind exhaust gases rushing off the engine. An exhaust-driven supercharger is known as a turbocharger. The turbocharger is here and it is mounted in between air filter and exhaust uh, exhaust pipe. Friends, now we'll work on plant room area requirement. The room area must provide adequate free space around the DG set for proper airflow, cooling and maintenance access. Specific CPWD NVC guidance mentions the foundation clearance. The PCC foundation should extend at least 250 mm more on all sides than the actual size of the diesel generating enclosure. Spacing around the generating set. For DG set installed in a room, open DG set in room refers to a generator without its own acoustic canopy installed within a built room. Specific minimum space requirement are recommended. Both the side minimum 1.5 meter, front side where the radiator hot air outlet is there minimum 3 meters, rear side minimum 2 meters. Ventilation opening, the fresh air inlet venting area should be minimum of 1.5 times the radiator area, and the hot air discharge opening area should be a minimum of 3 meter distance between two sacks. If you are mounting two different sacks, then a minimum distance of 1.5 should be maintained. Friends, this particular chart shows area and height requirement of diesel generating set room. Diesel generating set of different capacity from 25 kVA up to 2000. The area will be as given in this column, second column in square meter, and the clear height of the diesel generating room should be as given in the third column. It is in meter. The height as given in this table should be clear height below the soffit of the beam, if any. This must be kept in mind. Friend, there are two type of diesel generating set: naturally aspirated or with turbocharged. And third category is turbocharged intercooled. And this particular chart shows the D rating of diesel generating set as per altitude and inlet temperature. Different this one. And this particular slide shows two different things. One, minimum capacity of daily fuel service tank, which is provided with the diesel generating set when it is getting manufactured. This table shows the capacity from 25 kVA to 750 kVA, which is 9,000 liters. Now, second important aspect of this slide is DG stack height for different capacities. You know the diesel generating sets emits and discharges certain gases which are harmful to human being, and they must not be discharged uh, within nearby area. As such, stack height limitation has been added by CPCB. The uh, diagram on the left hand side shows the DG stack for two diesel generating set. One is this and the second is this. This fuel discharge right from top of the diesel generating set, even if it is canopy based. This height can be calculated with a formula H equal to 3 plus 0.2 multiplied by under root of kVA capacity. So in case of 500 kVA, it comes approximately 7.47 meters, and 750 kVA, it is 8.48 meters. But above 800 kV, the stack height has to be minimum 30 meters as suggested by CPCB, and it is compulsory for everybody providing diesel generating set for standby generating system. Friends, all generating set has to be canopy based. That means they should be enclosed with a canopy system which has got sound attenuation property due to insulation provided inside. Uh, this canopy looks like a cubicles system, and this is provided with silent type diesel generating set system, which are in all the cases above 750 kVA, that is from 800 kVA onward, must be canopy based as per CPCB. Friends, this diagram shows a diesel generator machine room where only one diesel engine is provided. This shows all the clearances which are required as per National Building Code, and the way of mounting the diesel generating set, which is with fuel tank. You have to provide a rolling shutter for entry and two windows. One is for cross ventilation, this window, and this is for side ventilation. And there may be a control panel and people sitting on that. Friends, this diagram shows elevational view of diesel generating room. In this, there is a diesel generating set, and it is provided with cross ventilation system, and this is the louvers provided in the side wall of the diesel generating room, and at the top exhaust fan is also shown, and it also shows how the exhaust gases are taken out through silencer up to stack system, stack structure. Friends, this particular slide shows typical ventilation system for cool for air cool generating set. Option A. Suppose the wind is blowing in this direction, then it suggests forced air system with an exhaust fan provided in the side wall and window provided on the other. So this creates a forced ventilation system. It also shows alternative location for the forced air. This comes like this. Remaining is exhaust gas through silencer to the stack structure. Friends, this slide provides the option V, ventilation system for the air cool generating set. In this, fresh air opening is provided in the side wall, and Exhaust fan is provided at the top. Remaining things are the same. Friends, this diagram shows in plan how two generating sets are to be mounted. You have to maintain 2000, that means 2 meter distances on either side, uh, but on the other side it is 3 meter, and on the radiator side it has to be 1.2 meter away. Friends, we have to take care of the foundational details as per CPWD General Specification for Electrical Works Part 7, Diesel Generating Set 2013. This is exclusive CPWD specification. It says generating set with acoustic enclosure for DG set installed inside the DG room, a PCC foundation of cement concrete water ratio of 1 to 2 to 4 M20 grade of approximately depth 150 above the finished generator room floor level is required so as to provide leveled surface for placement of the acoustic enclosure. The length and breadth of the foundation should be at least 250 mm more than on all sides than the size of enclosure. Generating set should be mounted on AVM inside the enclosure. Second provision, for DG set installed outside its open area with PCC foundation of given strength of weight 2.5 times than the operating weight of the generating set enclosure is recommended by our generating set manufacturer, OEM or OEA, whichever is higher, required to be provided and is included in scope of work for SITC generating set. 300 mm of this foundation height should be above the ground level. The length and breadth of the foundation should be at least 250 millimeter more on all sides than the side of an enclosure. Friends, this slide shows the installation of uh, generating set directly on the slab floor. Now it shows like this. This is the real ceiling, and this is diesel generating set, and it is provided with a foundation, cement concrete foundation, RCC foundation, and this foundation is resting on at least 200 mm of sand or gravel so that the structural the vibrations are not passed on to other structure. The generating set two spring type vibration isolation isolator anchored with type J or L volt as per detail given here are to be provided. In this slide, mounting details of electromeric vibration isolator or steel spring vibration isolator, and in the bottom diagram is shown how they take place in case of foundation, the skid is provided when the entire diesel generating set is mounted on a skid. Friends, this slide shows the typical depth of PCC foundation to be provided for soil bearing capacity of 5 ton per square meter. It has three columns. The KVA capacity, first column, second is without AVM, and with AVM, the depth of the foundation. Now AVM means anti-vibration mounts or anti-vibration pads. Friends, this shows a typical 11 kV generating set. Uh, if the campus is very large and buildings are quite apart, it is not possible to work with 430 volts or 415 standard voltage generating set and take hundreds of cable in the campus to feed electrical load in various buildings in the campus. So in such cases, uh, this type of 11 kV system is provided in combination with 11 kV second on from transformer. Either of the two will be feeding electrical load in the campus. Either means the one 11 kV generating set and the another 11 kV transformer. That means the supply is coming 33 by 11 and secondary side is 11 kV, and that secondary side of 11 kV through transformer and 11 kV generating sets are clubbed uh, in a automatic ATS transfer switch ATS, and only either of the supply will proceed further. This was experimented by me for the first time in Delhi Safdarjung Hospital when I was in charge of Safdarjung Hospital during 1995 to 2000. Uh, in there, I have revised the entire air conditioning system of the hospital, and these generating sets were provided as needed for air conditioning system and other supply. Friends, as said by me in the previous slide, I have provided 11 kV generating set, and there was a combined generating set room in AIMS All India Institute of Medical Sciences, Raipur, wherein I provided 11 kV generating set discharging uh, the the discharge coming out of the diesel generating set through a stack. So this is a combination of two diesel generating set at one place, and this shows the structure through which the flue gases are taken out from generating set. This is one, and this is another, and this is the silencer provided. This is the diagram or picture of sound attenuation of generating set up to 750 size. Friends, this slide narrates the diesel generating sets based supply system and transformers of AMS Here they are getting supply through three different transformer systems. These are 33 kV transformer system, and they are clubbed at one place through main receiving station. Now, this main receiving station is also provided with a SCADA control uh, control system. Now you can see from either of the three transformers are working in parallel. Similarly, three 11 kV generating sets are also working in parallel, and it is here they are combined. And after combining through a main busbar system or cable system, 11 kV system, they are connecting different substations. Say the substation one is having two of 1500 kVA capacity. This is another substation, similar capacity, and this is third, this is fourth. So how a number of substations can be provided in different buildings. This type of concept is prevalent in Dubai and Europe. Friends, this is a combined diagram providing transformers, generating set, and feeding different chiller of the air conditioning system. I am not discussing here the air conditioning portion. Let us take only this where we have this substation is having a metering room in which the electric supply which is coming here through cables or overhead structure, and the electric supply is metered here, and then it is brought to ST panel. Then there are two number transformers provided, and this remaining is support portion in which the engineer's room, toilet, store, and store shelves are provided. The second portion of this uh, has diesel generating set, two numbers, and AMF panel, two numbers, and at the corner petrol oil or lubricant room. This can be called diesel room in case of diesel fat generator, and in case of petrol it is called POL. All entries into these rooms, that means POL room and DG room, transformers, ST panel and metering panel are provided with ramp, and main entries are here. This is for transformer portion and this is for generating set portion. And the next one is for AC chillers. Dear friends, especially the consultant engineer, DG system project consists of one DG supply included with diesel generating set, AMF panel and oil tank. Second, DG stack work, raw cool insulation plus piping work plus exhaust work. as suggested by CPCBs, Central Pollution Control Board, and their agency in different states. Third, allied electrical system work. You have to design cable tray, earthing, plus uh, rubber mats, fire extinguisher, first aid devices, etc. Fourth item of design is HSD tank. You have to take care of supply installation, testing, commissioning of diesel HSD tank, high speed diesel. Obtain local approval and liaising work has to be done. First, obtain permission from government. Obtaining approval statutory from statutory bodies like Electrical Inspectorate, MSCB, that means State Electricity Board, supply authorities. Then Pollution Control Board. This is known as CPCB, is a local state-wise body. Then next is any other permission to run the diesel generating set. All above are design work on the basis of given BOQ. You have to prepare BOQ and provide specifications, etc. So thanks friends for watching this video series on diesel generating set standby mode.